Unit 2, Part 4. So we're saying, for the purposes of Quiz 1, okay, compare two sentences. Dan believes that Eden has a loose tooth, and Dan is Australian and Bruce is American. Those two sentences are both compound or complex, right? They both contain simple sentences as component, or they both contain sentences as components. Okay, so they're both compound for the point for the purposes of Quiz 1 when you'll be tested on this. And Dan believes that blank is a sentential operator. That's it's not a component sentence, but that's a sentential operator. It is itself an element of that sentence. Once you've got over the once you're familiar with the concept of sentential operators in general and the idea of a compound sentence in general, then, as I was saying, we are going to restrict our attention from then on, from now on, from Unit 3 on. We're going to be, Quiz 1's on Unit 1 and 2, but from now on we're going to be explicitly concerned with symbolizing sentences and analyzing the forms of arguments, symbolizing sentences, analyzing, working towards the truth tables, which will be the truth table test for an argument's validity. And in doing all that, we will, as I said, be ignoring the complexity of all sentences which are made up of sentential operators that are not this set of 5 over here, right? Only these 5 will be receiving symbols. Only sentences that are complex in that they are built up of these sentential operators, only that complexity will be expressed symbolically, okay? So the sentence, Dan is Australian and Bruce is American, that will get symbolized with the dot, that's the conjunction. Towards the end of Chapter 2, or end of Unit 2, you're introduced to these symbols and the structure of building up formulas from other formulas and so on. I'll talk a bit about that in a second. Dan is Australian and Bruce is American. That complexity will be represented. So Dan is Australian and Bruce is American will just be symboled like D for Dan is Australian, B for Bruce is American, right? So like so, right? The complexity is expressed symbolically or formally, right? You've got the dot, that's representing the sentential operator and blank, right? And the D and the B are the simple sentence. The D and the B are the component sentences of the whole sentence, Dan is Australian and Bruce is American. But the sentence, Dan believes that Eden has a loose tooth, we will be ignoring that complexity, right? The sentential operator, Dan believes that, will not be getting a symbol, right? So that sentence is just going to be treated as if it is a simple sentence in symbolizing sentences. Dan believes that Eden has a loose tooth, will be symbolized with some capital letter. Doesn't matter which one, but capital E, that will be the symbolization of that sentence, right? So even though it is officially compound, it does contain another sentence as a component, it does have that structure of component sentence inserted into a sentential operator, but we ignore that. Why? Why is that? Because these sentential operators are truth functional, whereas all the other sentential operators, including sentential operators like Dan believes that blank, are not truth functional. Okay, before I move on, I should stress one important point. A sentence like Dan isn't Australian, Dan is not Australian, you have to recognize that as a compound sentence, right? It's paraphrased. It can be, why is it compound? It can be paraphrased such that it does literally contain another sentence as a component. Dan isn't Australian is, it is not the case that Dan is Australian. That's the paraphrase, right? And that contains Dan is Australian as its component, right? So it is crucial to get that structure, the sentential operator not, as in it is not the case that blank, or just not blank I have over here. That is one of our truth functional sentential operators, one of our sentential operators that does receive a symbol. So whenever you see words like isn't, whenever you're translating isn't or wasn't, you have to see that, you have to see the structure in that. You have to see that as the negation of the positive sentence, right? Dan wasn't in Australia it is not the case that Dan is, or it is not the case that Dan was in Australia. Right? Dan isn't Australian, it is not the case that Dan is Australian. Because that structure will get symbolized, right? Dan isn't Australian, the proper symbolization is not A, or let's make it not D, right? D equals Dan is Australian, not D, this is the tilde. Tilde is the symbol for not. It is not the case that Dan is Australian. See, the structure is represented. Okay. Good. All right. So the rest of this chapter, you should really read through it, but it introduces you to the important use of parentheses in distinguishing how formulas are built up. So formulas are representations of sentences. Right? The simplest formulas are just the capital letters, right? A, B, D, and now these symbols over here, so this is the list of our sentential operators and the symbols for them. These are rules for the construction of more sentences, right? So the sentential operator and, which is just blank dot, blank and blank, it's symbolized as so. This is the formula. And think of this as a rule which just says, given any sentences, given any two sentences, you're entitled to build another sentence, right, simply by conjoining them, or right, putting one sentence here and one sentence, another one here, right, or one formula here and one formula here. Any formula of any complexity. It can be A or B or D, or it can be, right, so here. I've made one sentence here, right? I've conjoined these two simple sentences. So this is Dan is Australian and Dave is American, or whatever. And now I can take that formula and I'm entitled to build another conjunction, right? It's just a rule that says you're entitled to make a new sentence by putting any new formula, by making any formula there, putting any formula there, and any formula there. I can do it here by putting that whole thing here, A and D, in parentheses, and then let's say F, right? And what this says, and what the parentheses tell you, the parentheses indicate the order of the construction of the formula, right? So this says, first we had A, D, and F, just those simple sentences, and then we conjoined, first we conjoined A and D, right? So we made that conjunction, and then we conjoined A and D and F, right? We conjoined that and that. So when we come to determine the truth values of these, which I think is in Unit 3, right? We have to first, whether this whole formula is true or false, right, is whether the conjunction of this and this is true or false, right? So the truth table, which we introduced, I think, you introduced to in Unit 3, the truth table for the conjunction is just, the conjunction is true only when both conjuncts are true, right? The meaning of blank and blank is just any such statement is true only when both of the component sentences are true, right? So it's this that has to be true here, and we'd have to first determine the truth value of this, right? You need the truth value of these, then determine the truth value of this component, and then, right, you'd work out that before you work out that.